Okay, some of the kids were struggling a little bit with some of our mineral lessons, so I think that we need a video lesson to explain it a little bit. First of all, that intro page, they don't give a lot of information about what you see here. This really cool cave is in Mexico, in Chihuahua, Mexico, and those are selenite crystals. And it's about 1,000 feet underground, and two brothers found them in the year 2000. They were digging down to make a mine for other stuff and happened upon these. It is like 200 and some degrees down there or something crazy like that. It has since all filled back in with water. When it looked like this, and you could go in and you could check it out, you could only stand there about 10 minutes and it was dangerous, so you had to go back out again. Since it has flooded, the hot water that is in there is actually causing these crystals to get even bigger. Some of these are like 38 feet long. So that was pretty cool, I thought, on that page. I'm just going to hit some of the high points. Animal, vegetable, or mineral. Our last lesson was all about sorting animals into different groups, and scientists love to sort. So not only do we sort animals and plants, but we also sort minerals. So everything in the world is going to fit into one of these three categories. What do minerals have in common? What are they? To be a mineral, it says it is a naturally occurring, usually inorganic solid that has a definite crystalline structure and chemical composition. Well, what does all that mean? Well, definite chemical composition means it's made out of things on the periodic table. For example, this cool little bismuth crystal out of our classroom is made of only bismuth. That's the chemical that makes it off the periodic table. The quartz crystals that people like to make jewelry out of and wear around their neck, and it's used in all kinds of electronics, is made out of silicon and oxygen. It's made out of two things, but definitely there's some chemicals off of the periodic table that make them up. So every rock and mineral that we pick up, we can figure out what things from the periodic table would be put together in a big mixing bowl to make that happen. They are solid. We've never seen rocks that aren't solid. If you go to Hawaii or to a volcano somewhere, you see lava that has come out of the volcano and it's molten, it's melted, but as soon as it cools down, it's going to go right back to solid. Usually inorganic. Inorganic doesn't that doesn't have anything to do with spraying pesticides and stuff. That's a different definition of organic. Organic means that it came from something that's alive. So anything that came from a plant or animal, all of those things are organic. If it's inorganic, that means it didn't come from an animal. So all of these rocks and minerals are not alive, but something like a pearl, that one's not a mineral because it was made inside of a clamshell. The outside part of a seashell is made of calcium, but that is made by an animal, so that's not a mineral. It says usually inorganic because there are a couple of exceptions. If you know anyone that's ever had kidney stones, that's a little tiny stone that's the minerals that gather in your body. That is a stone that actually kind of counts as a mineral. It is made by something that's alive. The crystalline structure is what our whole lesson's going to be about, so I'll come back to that here in a second. Naturally occurring, it means it has to be out in nature. On Earth, the mineral halite is something that we use for table salt. We salt it right on our food. That is something that's naturally occurring. We don't have to make salt, it's there. And it says it forms as water evaporates and leaves behind the salt that is contained. Did you know that there is a salt mine underneath of Lake Erie? They actually tunnel underneath of there, and there are great big pillars of salt that are in place to hold it up, and they are mining it out and hollowing it out underneath there. They used to give tours of that, but because it's a bit dangerous for the public, they don't do that anymore. I'm kind of bummed. As claustrophobic as I am, that would be really neat to see. So back to the crystalline structure. Here's a definition of crystal, which is something that you guys will do on your homework. It said a crystal is a solid geometric form that results from a repeating geometric form. Oh, sorry, I repeated myself. A crystal is a solid geometric form that results from a repeating pattern of atoms or molecules. The paper that you guys had to do asked what a crystal was, and right up here in that very first sentence, It says the visible shape of a mineral's atom pattern is called a crystal. So both of those definitions say something about the atom pattern. Some of you tried to use Google instead of reading the things here, and there's a lot of different definitions of crystal. But when we're talking about minerals, I really needed you to use the one that comes from our book. It's about the patterns of the atoms. So a little bit about that. Right here we have some quartz. Same as this, comes in a couple different colors. That is quartz right there. And it is made of oxygen and silicon, these things from our periodic table. So when you are doing that, you need 1 silicon and 1, 2, 3, 4 oxygens that all stick together. That is one molecule of that. So that it says an atom of silicon can typically bond with up to 4 oxygen atoms to form a molecule. 1 or more of these molecules form a compound, so that means they're going to join together with others. Those of you who build with Legos or some of those other things know that there's only a certain way they'll go together. Well, these only snap together in a certain way. And I kind of drew this little triangle overlapping thing, kind of looks like the Star of David. If you look here, you can see that. Here's a triangle, here's another triangle, and then if we take our pencil and we go around the outside edge, 1, 2, 3, 4, 5, 6. There are 6 sides to that right here. 1, 2, 3, 4, 5, 6. Look in your book and see if you can see that little Star of David thing there that makes a 6-sided shape. If you look at the end of my crystal, it also has those 6 sides. So I will put close-ups of these later so you can see that a little bit better. So that's what makes a definite shape, why all of our crystals have a different shape. You had some questions here to answer, so let's just see if we can run through that about comparing the cardboard and the topaz. If you were born in November, like I was, topaz is your birthstone, and it is one of the minerals, but we're going to check this checklist to see if it is. So first of all, definite chemical composition. Cardboard, they already said no, because we have no idea what they mixed together to make that cardboard. We know that cardboard is made of paper, made of trees, but they put some other stuff in there. Topaz, yes, it does have a definite chemical composition. It's made of silicon and oxygen, just like this, but it also has in it some aluminum and some fluorine and some hydrogen. All of those things go together to make that topaz. So yes, it has a definite chemical composition. Solid, is the cardboard solid? Yeah, it's pretty solid. It's definitely not a liquid. And the topaz, they already said yes, it's a solid. Is it inorganic, not alive? The cardboard is not inorganic. It was alive. It used to be a tree. That's why we want to recycle those things. Is the topaz inorganic? Yes, inorganic. It's a rock. It's a mineral. Naturally occurring, comes from nature. Well, the cardboard came from a tree, but do you go outside and pick cardboard boxes in the garden or pick them off of a tree? No, so we're not going to say it. That one's not naturally occurring, but the topaz is naturally occurring. They can find that and they can mine it out of the ground. Crystalline structure. Does a cardboard have crystals? They already said no. Does the topaz have crystals? It does. We can already see that, so we're going to put yes. So, is it a mineral? Cardboard has a lot of no's. It's a solid, and that's about it. The topaz has all yeses. It checks every single one of these boxes for a definition of what a mineral is. So yes, the topaz is a mineral, and no, the cardboard is not. Okay. On to the next page, crystal clear, how are minerals formed? And don't forget that when you're answering your questions at the end of the chapter, that when they ask a question in blue, they usually answer it in red. So don't forget that tip. That's going to help you a lot when you get into 7th grade and use the same book series. So how are minerals formed? One way is as magma and lava cool down. The second way is through metamorphosis. And the third way is from solution. So I wrote those 3 things there. So as magma and lava cool down, we know that makes obsidian. We have some of that in the classroom, some of that black glass that we've seen before. It says as magma cools, the atoms join together to form different minerals. Minerals also form as lava cools. Now wait a second, they said magma and then they said lava. Aren't those the same thing? They're not the same thing. Do you remember the difference? We've mentioned before, drew a little picture up here. It's magma when it's inside of the volcano, and it's lava when it's outside the volcano. I wrote a little note here. Lava has left. The lava has left. So if you can see it from the outside of the volcano, you're looking at lava. If you're talking about underground, that's the magma. So when those things cool down, the ones underground cool down much more slowly, make a bigger crystal. The ones on the surface cool down much more quickly, make a smaller crystal. And that's going to answer our number 7 here. How are the ways in which pluton and pegmatite minerals form, are they similar? So if we look here at these lovely little pictures that we see here, this one is a pluton and this one is a pegmatite. This one says magma that cools very slowly. This one says magma, as magma rises, it can stop moving and cool slowly. So this one cools very slowly and this one cools slowly. So they are both very slow cooling rocks. I wanted to mention the salt here because, I skipped one, sorry. This metamorphism one, the cooling magma, makes these rocks that we see all over the place that are pink and black and white. Those are 3 different minerals all stuck together, and those have formed deep, deep, deep underneath of the volcano. Metamorphism is not just the heat, but also the pressure. So it's hot and melted, like the lava ones, and lava and magma over here, but there's a lot of pressure too. The crystals, most of the crystals that we see, were either from heat or from this solution. So it says they precipitate from evaporating solutions, like when you leave a glass of water in your bedroom and then later there's all that white dust in the bottom. Well, as the water evaporates, it leaves behind the calcium and the lime, and that's how we get salt. I have a large salt crystal here. This one took a good old long time and formed very slowly. One tiny little crystal and others grew around it, so no one disturbed it for a very long time. Gives us a really big salt crystal. This one over here, it says it can precipitate from a cooling solution on Earth's surface. So both of these are from solutions. Salt water can evaporate, or something that's hot can cool down. This is how we made the video about the borax crystals. That was very hot, and as it cooled down, that happened quickly. This took a very long time, but this happened overnight. Down underneath it here, we see another one, precipitating from cooling solution. And precipitate means it's fallen to the bottom. Precipitation outside, rain, snow, falls down in the bottom of our glass. When things fall down, they precipitate. So from this cooling solution beneath Earth's surface, water works its way downward and is heated by magma, and then it reacts with minerals to form solutions. Dissolved elements such as gold precipitate once the fluid cools to form new mineral deposits. So that's why when you're watching those Old West movies, they find a vein of gold. It's in a line because that's where the water trickled in and it carried those minerals with it, and then it hardened. I'm not really going to say too much about the next 2 pages, and that's where we'll stop with that. It says sort it all out. How are minerals classified, and how are they going to sort those? I wrote a little note up here. These are nice to know, but not need to know for us in 6th grade. There's 2 big groups. There's silicate minerals, and if it's a silicate mineral, then it has silicate in it, hence the name. And then there's non-silicate minerals. They don't have any of this. So all of these are non-silicate minerals, and some of you wanted to write these down on your paper when it asked for the 6 different crystal shapes. These are classes. These aren't crystal shapes. So we don't really have to do a whole lot with that. That's nice to know, but not a need to know.